photometric image formation. Photometric image formation is composed of three things. One is digital camera, one is surface, another one is light source. Okay, whenever the light source hits the surface, it will be reflected to the camera and the image is formed. There will be an image sensor inside the camera. So, definition of photometric image formation is it is nothing but the process to generate the intensity values in an image by interaction of light, surface properties, and the camera optics and sensors character. So it is comprised of three things, as I said earlier: light, surface, as well as camera and its sensors. First, let us see about lighting. So, image can't exist without light. To produce an image, the scene must be illuminated with one or more light source. So, light source can be generally divided into point light source and area light source. Point light source means it originates at a single location, example a small light bulb. In case of area light source, we can take an example of a fluorescent ceiling light fixture, which can diffuse a light in a finite rectangular area, thereby emitting light equally in all directions. Okay, so the point light source means it's a single location. Here it will have multiple directions of light. So we are representing the light in the form of light direction as well as wavelength. Light direction is represented by d vector, and lambda represents the wavelength of the light. Three types of light are ambient, diffuse, and specular. Ambient light is a uniform light, diffuse is scattered light, and specular is a mirror-like reflection. So next one is surface properties, reflections and shading. Whenever light hit an object, it is scattered and reflected. So this is incident light. Whenever it hits the surface, it is reflected, and this n represents the surface normal. The most general model of light scattering is represented using this function, bidirectional reflectance distribution function. It is four-dimensional function. It is based on the incident direction as well as reflected direction. Okay, the incident direction is nothing but the incoming light direction. So let us see the surface, and the incident direction is represented as Vi. On hitting the surface, it will be reflected. It is considered as Vr. So, in order to represent Vi, we have two terms, theta I and psi I. To represent reflected direction, we have two terms, theta R and psi R. Let us see a diagram. You could get a better understanding. So, this is my surface, 2D surface. So, each surface will have a x as well as y. This x and y is called as a tangent vector, and this surface is represented using surface normal. So on combining this x, y and n, we can represent the coordinate as dx, dy, n. Okay, so on hitting the surface, it will be reflected. So the incident light is represented as Vi, and the reflected light direction is represented as Vr. The angle between incident light direction and surface normal is represented as theta r, and the angle between the reflected light and the surface normal is represented as theta r. Let us draw a perpendicular line like this. The angle between this dx and the perpendicular line is known as psi I. Similarly, the angle between the perpendicular direction and the dx is known as psi r. So it is a combination of theta I, theta r, psi r. Note here BRDF is reciprocal, which is also known as Helmholtz reciprocity, which means you can interchange the roles of VI and VR, we will get the same answer. So if the incident light comes from this direction and it is reflected in this direction, means that theta between the surface normal and incident and reflected light would be same. So we can interchange this roles of VA and VR. So VRDF is reciprocal. So let us consider the surface as isotropic or non-isotropic. If the surface is isotropic, means there is no preferred direction on the surface. Okay, which means if we rotate the surface like this, the theta value won't be changed between the incident and reflected light. So in case of isotropic material, we can simplify the BRDF into difference between psi r minus psi I. So the individual psi r and psi r is not required. Instead, we can take only the difference between psi r and psi a. So we can also represent it as vi, vr, and n. In order to calculate theta I and theta r, in order to calculate theta I and theta r, we only require vi, n, and vr, right? So if the surface is isotropic, we can change or we can simplify the BRDF as psi I comma psi r, determination of psi r minus psi I, or we can represent FR of VI vector and VR vector n. I represents incident vector, R represents reflection vector. Okay, so now let us see if the light is, we have done with surface. If the surface is isotropic, we can simplify this. Now let's check whether the light is coming from the continuous direction or not. Okay, if the light is from the continuous direction, then we have to take the integration. If the light is from the discrete, we have to take the summation. We have to replace the integration with summation. So we have seen this formula earlier in the light equation, right? So the light is represented as v vector comma lambda. So we are going to determine reflection amount, right? Reflected direction as well as wavelength using the incident one. So Li of Vi comma lambda, it represents incident light direction as well as incident light wavelength. This term represents simplified BRDF, right? Simplified BRDF, and cos plus theta I. This represents foreshortening factor, which is nothing but the angle between theta I, right? So theta I, we already know it is the angle between Vi to N. If this angle increases, then the intensity is decreased. So and D and VA, four terms. One is incident light direction as well as wavelength, then simplified BRDF, foreshortening factor, then D into VI. So in this case, we have to use when the light is continuous. When the light is discrete, we have to replace the integration with summation, and you can see there is two changes. VI is omitted, right? So here VI term is omitted because we don't know the direction of the light. If assume the surface is getting different direction of light, then it is not continuous. So VI represents the direction. VI represents the direction. So we can determine the direction only if it is continuous. So we are omitting the VI. Next one is diffuse reflection and Lambertian model. It is also known as a Lambertian model or matte model. Okay, so in this case, the light is scattered uniformly in all direction. Okay, next we will see specular reflection. Here, the light will reflect on a smooth surface. Okay, or generally we can say diffuse reflection. It will more suitable to reflect a light in rough surface. In case of specular reflection, will deal with smooth surface. Okay, so rough surface, so the surface is not smooth. I'm going to take one ellipsoidal surface. So Vi, this represents the incident light. If it directly hits on the smooth surface, look at the maroon arrow, it represents the incident light direction, and dot product of V and N, Vi and N becomes 1 if it directly hits the surface. If it hits the edge, means then the dot product value between Vi and N is ranges from 0 to 1. If it if the light, if the incident light falls on the lower edge of the rough surface, then the dot product between incident light and the surface normal would be 0. And if it falls at the bottom of the rough surface, means the value will be less than 0. So whenever the light hits the bottom area, the dot product between the incident light as well as the surface normal will be less than 0. Whenever it hits exactly the mid of the surface, then the value would be 1. So the value ranges from 0 to 1 if this dot product between Vi and N is closer to 1, means I can get a good image. If the value is close to 0, means I'll get a shadow. So if you take a photo, this place would be a shadow, this place would be the brighter one. So in this case, in this case, we are going to say the VRDF is constant when light is scattered uniformly in all directions. Okay, assume this is the rough surface. If the light is falls in all direction, then the VRDF would be constant. So I am just representing only the lambda value, right? Then in case of specular reflection, we can say a smooth surface I am going to consider a mirrored surface. If the light gets hit on the mirror, the reflection will be different than the rough surface. So consider this as a smooth surface or mirror. Whenever a light hits, this VI represents the incident one, it will be reflected. So this represents V parallel and this represents V perpendicular. The angle between this becomes 180 degree. It will be exactly 180 degree. But if the surface is uneven, we can't get any exact 180 degree of reflection. So in case of smooth surface, we can say the reflection will be the angle between the perpendicular distance of incident and reflected will be 180 degree. So it can say we can say it depends strongly on the direction of the outgoing light. We'll see this in the upcoming part video. Thank you.